Select the correct statements. At Boyle's temperature, a real gas behaves like an ideal gas at low pressure. If we try to remember the definition of the Boyle's temperature, what was it? It was that temperature at which in the low pressure region, a real gas would show ideal behavior. That is, if this is the Z is equal to 1 line and this is the pressure, in the low pressure region, that is this part of the curve, this curve is showing the maximum inclination towards ideal behavior. And so this curve is at the Boyle's temperature. So at Boyle's temperature, a real gas behaves like an ideal gas at low pressure. Absolutely correct. Above critical conditions, a real gas behaves like an ideal gas. Now when we talk about situations above the critical conditions, we say that above the critical conditions, the gas cannot be liquefied, right? Because the forces of attraction are not present because of the high kinetic energy above critical conditions. Correct? Therefore, since there are no forces of attraction or no interactions among the particles, it would mean that it is similar to an ideal gas behavior. Therefore, above the critical conditions, a real gas does behave like an ideal gas. Now, for hydrogen gas, B dominates over A at all temperatures. Now, let's see what this means. If we look at the curve, the Z versus P curve for hydrogen gas, this is what it looks like. Okay. So at low pressure, the Z is less than 1, and at high pressure, the Z is greater than 1 for hydrogen, right? And if we write the Vanderwaals expression, okay, it will be what? P minus A by V square times V minus B is equal to RT, right? At low pressure, this term gets neglected. So what we have is that P minus A divided by V square into V is equal to RT. And Z at low pressure conditions comes out to be 1 minus A divided by RTV, right? And for the high pressure conditions, if we talk about this, what we have here is that A divided by V square would get neglected. So we have PV minus B is equal to RT. And here when you divide by RT on both the sides, we get Z is equal to 1 plus PB divided by RT, right? So if we see at low pressure and at high pressure, A and B get neglected. So we cannot say that at all the temperatures B would dominate over A, because at say any temperature but at low pressure, B is being neglected. It is not dominant. Therefore, statement C is incorrect. Then we talk about statement D. At high pressure, Vanderwaals constant B dominates over A. So here we have high pressure. At high pressure, we have neglected the term containing A, which means that the Vanderwaals constant B does dominate over the Vanderwaals constant A at high pressure conditions. So statement D is correct. So our correct answers from the given statements are statement A, B and D.